Hello my dear learners, welcome to my video lecture on belt drives. In this video lecture I will be explaining how to solve the numericals on belt drives. There are various parameters that we have discussed in the previous video lectures wherein I talked about the velocity ratio, length of open belt drive, cross belt drive and ratio of belt tension. So how to find out all these parameters we'll see in the numericals. I have taken a couple of problems wherein which is given to find out those parameters. So this video lecture is presented by me, Shamant, working as an assistant professor in Global Academy of Technology. So let us begin our today's lecture. So before I start the numericals, let us just have a recap of the formulas that we have understood in the video lectures that I have explained in the explained previously. The first one is the velocity ratio definition, the formula for the velocity ratio. It is given by n2 by n1 is equal to d1 by d2, where n2 is the speed of the driven and n1 is the speed of the driver, and d1 and d2 is the diameter of the respective driver and the driven pulleys. And then when velocity ratio is to be found out when slip is considered, then you have to add the slip into consideration. N2 by N1 is equal to D1 by D2 into 100 minus S by 100 will be the formula when slip is considered, where S is the percentage slip. Then length of the open belt drive, we derived that and we arrived at L is equal to 2C plus pi into R1 plus R2, R1 minus R2 whole square by C, whereas cross belt drive, the length is equal to 2C plus pi R1 plus R2 plus R1 plus R2 whole square by C. You can easily remember these two length because only difference between an open belt drive and cross belt drive is the negative sign in the third parameter, that is R1 minus R2, and in cross belt drive it is R1 plus R2 whole square by C. So I don't think you will have much confusion to remember the length of the open and cross belt drive. And then angle of contact. Angle of contact is very much important because if it is not given, you need to calculate, and it says for an open belt drive you need to consider the smaller pulley and the angle of contact at the smaller pulley, and that is given by theta is equal to 180 minus 2 sin inverse R1 minus R2 by C into pi by 180 radian. So the first formula is for an open belt drive. And for a cross belt drive, theta is equal to 180 plus 2 sin inverse R1 plus R2 by C into pi by 180 radians. So in the cross belt drive, the angle of contact will be same for the larger pulley as well as the smaller pulley. So you need to see the difference here. If it is negative in the R1, in the numerator of the parameter R1 minus R2, then it is for open belt drive. If it is positive R1 plus R2 by C, then it is for cross belt drive, and this angle of contact theta should always be in radians. So that is why we are multiplying the value by pi by 180. So when you multiply by pi by 180, you will get it in terms of radians. And then power transmitted in a belt drive. So we are mainly concentrated on calculating the power transmitted. So to calculate this, the formula is P is equal to T1 minus T2 into V by 1000 kilowatt, where T1 and T2 is the tensions in the tight side and the tension in the slack side. V is the velocity and 1000 is the conversion factor into kilowatt. And V is given by pi d1 n1 by 60 or pi d2 n2 by 60 meter per second. So you can calculate the velocity by using the formula, and velocity should be in terms of meter per second if you have to calculate the power in terms of kilowatt. So if it is in meter per minute, you have to convert into meter per second and then substitute the value in power formula. Then initial tension in a belt drive is given by T naught is equal to T1 plus T2 by 2 Newton. So sometimes in the problem they might ask you to find out the initial tension. After finding out the tension in the tight side and the slack side, then you have to just take the average of both the tension. That will give you initial tension in the belt drive. Ratio of belt tension in a belt drive is given by T1 by T2 is equal to e power mu theta. Even this we have derived T1 and T2, again tension in the tight side and the slack side, e power mu is the frictional force, coefficient of frictional force, and theta is the angle of contact. So these much formulas are required for you to solve the problem. So let us start solving the problem. We'll see one by one how exactly to solve the problem. So first numerical says a shaft running at 100 rpm is to drive a parallel shaft at 150 rpm. So when you are reading the question, you need to understand what is driver, what is driven. So sometimes they will give you the driver and driven directly. Sometimes they will not give, they'll give you just larger pulley and then smaller pulley. Then you need to identify which pulley is or which is driving what. The pulley on the driving shaft is 35 centimeter in diameter. They have given the diameter of the driving shaft. Find the diameter of the driven pulley and calculate the linear velocity and velocity ratio of the belt drive. So what is that you need to find out? You need to find out the diameter of the driven pulley. So D1 is given, that is the driving shaft. So driver, they have given N1 is equal to 100 rpm, and then D1 they have given in terms of centimeter, 35 centimeter. When they have given in terms of centimeter, you need to convert into meter. So you need to follow one unit. So always we will take meter as the unit. So when you convert 35 centimeter into meters, it becomes 0.35, that is 35 by 100, 0.35 meter. And the driven pulley, the N2 value is 150. So it is driving at 150 rpm. And then D2 you do not know, you need to calculate. So how do you calculate D2? So you need to think about it. So solution, to find D2, we are considering the formula of velocity ratio, because N2 is known to us, N1 is known to us, and D1 is known to us. D2 is the only one unknown here. So you can easily find out D2 using this formula. Substitute the values. N2 is 150, N1 is 100, D1 is 0.35 meter, and D2 is the unknown here. Simplify, you will get D2 as 0.233 meter, or you can keep it in terms of the centimeter unit, because in the problem it is given in terms of centimeter. Convert into centimeter. D2 is equal to 23.3 centimeter. Next one, what you need to find out. So diameter of the driven pulley is found out. Calculate the linear velocity and velocity ratio of the belt drive. So velocity ratio you can calculate. Again, you have the formula N2 by N1 is equal to 150 by 100. 150 is the speed of the driven pulley, and 100 rpm is the speed of the driving shaft. So it is 3 by 2. Velocity ratio is equal to 3:2. Then the next step is to find the linear velocity of the belt. Linear velocity of the belt is equal to pi d1 n1, or you can consider pi d2 n2. So this pi d1 n1 is in terms of meter per minute. If you want meter per second, then you have to divide by 60. Just substitute the values, because you know all the values. Pi into d1 is 0.35 meter, n1 is 100 rpm. You can either consider pi d1 n1 or pi d2 n2, it is left to you, but the answer will be same, 109.95 meter per minute. Upon simplification, you will get this value, and this has to be in terms of meter per second. So I have divided by 60, you get V is equal to 1.83 meter per second. So this is how you calculate the unknown terms as well as velocity ratio and then linear velocity. I hope you have understood this problem. It is very simple. You need to only calculate the diameter of the smaller pulley and then velocity ratio and then the linear velocity. So it is simple problem. So next, numerical. An engine shaft running at 200 rpm is required to drive a generator at 300 rpm. So by this you can identify what is driver and what is driven. So this is the driver, 200 rpm, and then driven is a generator shaft which is driven at 300 rpm by means of a flat belt drive. Pulley on the driving shaft has 500 mm diameter. So that means they have given the diameter of the driving shaft, which is 500 mm. Determine the diameter of the pulley on the generator shaft. Here you need to determine the diameter. Same as your previous case, that is in the previous numerical we found out the diameter, but here for that they have added a condition saying if the belt thickness is 8 mm and slip is 4%, then you have to find out the diameter of the pulley on the generator. So given, write down all the things which is given driver you have N1 200 rpm, D1 is 500 rpm, convert into meter, 500 mm into meter, it is 0.5 meter. And driven pulley N2 is equal to 300 rpm. You need to calculate D2, but by considering the belt thickness and slip. So thickness of the belt is 8 mm, convert into meters, 8 into 10 raised to minus 3 meter, slip is 4%, and find D2. So velocity ratio when you consider belt thickness will be N2 by N1 is equal to D1 plus T divided by D2 plus T into slip is to be considered 100 minus S by 100. So if you are not considering thickness of the belt and slip, then velocity ratio will be N2 by N1 is equal to simply D1 by D2. If you are considering the thickness and slip, then you have to add the thickness to the diameter value D1 plus T by D2 plus T, and then slip you have to consider, and then substitute all the values. N2 is known to you, that is 300 rpm, N1 is known to you 200 rpm, D1 is given 0.5 meter, D2 you need to find out, thickness is given, that is 8 into 10 raised to minus 3, and slip is also given as 4%. Substitute all the values, D2 is the unknown, simplify, take D2 plus 8 into 10 power minus 3, which is in the denominator, to the left hand side, and move all the other terms to the right hand side. Then simplify, you will get 0.325. So D2 plus 8 into 10 raised to minus 3 is equal to 0.325. Simplify the value and then get the answer. D2 is equal to 0.317 meter, or since the diameter of the driving shaft is given in terms of 5 mm, convert that meter into mm and then keep your answer. So the final answer should be in terms of millimeter, just because the pulley on the driving shaft is given in terms of millimeter. 317 millimeter is the diameter. So this is how you find out the unknown terms. That is, generally when the diameter is asked to find out of either of the one pulley, then you have to look into the question saying whether the thickness and slip should be considered. If the thickness and slip should be considered, then you have to use this formula. If the thickness and the slip is not considered, then you can just use N2 by N1 is equal to D1 by D2 and then solve the problem. So the next numerical, the third one, in a cross belt drive, the difference in tension between the tight side and the slack side is 1200 Newton. If the angle of contact is 160 degree and the coefficient of friction is 0.28, find the tension between slack and tight sides. Also, determine the initial tension in the belt drive. So, they have asked you to find the tension between slack and tight sides. You need to find T1, you need to find T2, and also they have told you to determine the initial tension in the belt drive. So when I explained you about the formula, the initial tension in a belt drive is given by the formula T0 is equal to T1 plus T2 by 2 Newton. So you need to use that formula. So they have given difference in tension between tight side and slack sides, that is T1 minus T2 is given to you, which is equal to 1200 Newton. Just write it as equation number 1. They have given angle of contact, that is 160 degree, and while explaining angle of contact I told you it has to be in terms of radians. So convert 160 degree into radians, 160 into pi by 180, which is equal to 2.792 radians. And then they have given you the coefficient of friction, which is mu, which is equal to 0.28. So now let us see how to find out the tension between slack and tight side and also to determine the initial tension. So you need to find T1, T2. They have given mu and theta. So take the ratio of belt tension. Consider the formula T1 by T2 is equal to e power mu theta. Substitute for mu and theta. Mu is given as 0.28 and theta is given as 2.792. So that is in terms of radians. So from here you will get T1 is equal to, when you simplify e power mu theta, e power 0.28 into 2.792, you will get it as 2.185, and T2 you just transfer it to the right hand side, you will get T1 is equal to 2.185 T2. That is your equation number 2. In equation number 1, what they have said, T1 minus T2 is equal to 1200. So T1 minus T2 is equal to 1200, but T1 you have got it as 2.185 into T2. Substitute 2 So from 1 we have T1 is equal to 1200 plus T2. So from here T1 is equal to 1200 plus T2, that is your equation number 3. But from 2 we have T1 is equal to 2.185 into T2. So substituting equation number 3 into, so when you substitute 3 into, you get 2.185 T2 is equal to, so for T1 you are substituting, what is T1? 1200 plus T2, that is what we have substituted. From here you will get T2 is equal to 1012.65 Newton after simplification, that is slack side tension. So T2 is always taken as slack side tension, and then T2 you have got, substitute in equation number 3, then you will get T1. T1 is equal to 1200 plus what is T2? 1012.65 Newton. Then T1 will be 2212.65 Newton, which is the tight side tension. So you have found out T1 and T2. So find the tension between slack and tight side is found out. T1 and T2 is found out. What you need to find out? Also determine the initial tension in the belt drive. What is initial tension in the belt drive? It is given by T0 is equal to T1 plus T2 by 2. It is just the average of two tensions. Just substitute the values, 2212.65 plus 1012.65 by 2. Your value will be 1612.65 Newton. That is the initial tension in the belt drive. So this is how you will solve to find the initial tension, and then tension in the slack side, and then tension in the tight side. Moving on to the next type of problem. So in the three problems that I have discussed the different type of parameters to find out. Now the fourth one. So this is very much important. This is the type of problem that will arrive in your examination. So be little careful and understand the numerical clearly. So the driving shaft rotating at 150 rpm drives the driven shaft at 250 rpm. So here the driving shaft is rotating at 150 rpm and driven. So this shaft is driving the another shaft at a 250 rpm. The distance between the centers of the two shafts is given as 2.7 meter, and the pulley mounted on the driven shaft has 60 centimeter diameter. So driver N1 is given to you, that is 150 rpm. Driving shaft is 150 rpm. D1, the distance between the centers is 2.7 meter, that is C. C value is given 2.7 meter. And the pulley mounted on the driven shaft. So driven shaft D2 is given 60 centimeter, which is equal to 0.6 meter. And then N2 of driven is 250 rpm. Assuming the coefficient of friction between the belt and the pulley rim as 0.25, what is this value? It is nothing but mu. It is 0.25, coefficient of friction. Then tension at tight side of the belt as 4800 Newton. They have given T1 4800 Newton. Determine the length of the belt. So you have to find the length of the belt L, belt tensions, that is T1 by T2, and then power transmitted for open and cross belt drives. You need to find three parameters: length, belt tension, and power transmitted for both open and cross belt drive. So in this numerical, I will be solving for one particular belt drive, that is open belt drive, and on similar lines you will solve the cross belt drive. So driver N1 is equal to 150 rpm. So all the given data you just write it down, and then first we'll find out the length of the belt for open belt drive. I am solving for open belt drive. On similar lines you solve it for cross belt drive. So to find length of belt, L is equal to 2c plus pi r1 plus r2 plus r1 minus r2 whole square by c. When you are finding out length of belt for cross belt drive, this will become r1 plus r2. So now substitute the values. You know C is given to you, and then R1 is given to you. Sorry, R1 is not given. You have to find out. D2 is given, that is 0.6. From here you can get R2, that is 0.6 by 2, that is 0.3 meter. So R1 you need to find out. How do you find out R1? That is D1. So for that, take velocity ratio. N2 by N1 is equal to D1 by D2. From here, you know N2, you know N1 and D2. So find out D1. D1 is equal to N2 into D2 by N1, which is 250 into 0.6 by 150, which gives you 1 meter. R1 is equal to D1 by 2, that is 1 by 2 is equal to 0.5 meter. Now you got R1 value, just substitute in the length of belt equation. So length of belt equation is equal to 2c plus pi R1 plus R2 plus R1 minus R2 whole square by c. This is for an open belt. Substituting the values that you have got, 2 into c is 2.7 plus pi R1 you have just calculated, which is 0.5 meter, plus 0.3 meter is already given to you as R2, and 0.5 minus 0.3 whole square by 2.7. Upon simplification, you will get the value as 7.92 meter for open belt drive. So you have found out the length of the belt. Next, you need to find out belt tensions and then power transmitted. So to find belt tension, so if you want to find out belt tension, that is T1 by T2, then you will have to find out theta, that is not given, and T2 is not given to you. So calculate theta. So how do you calculate theta? For open belt drive, angle of contact is equal to 180 minus 2 sine inverse R1 minus R2 by C into pi by 180. If it is for a cross belt drive, your theta will be 180 plus 2 sine inverse and R1 plus R2 by C into pi by 180. So for cross belt drive, both are positive. For open belt drive, both are negative. Substitute the values. You have R1 value, you have R2 value. Find out the theta value. 180 minus 2 sine inverse. R1 is 0.5. R2 is 0.3, C is given 2.7. Simplify, you will get it as 2.993 radians. Once you get 2.993 radians, substitute in the e power mu theta. So theta is known now. Mu is given as 0.25, e power 0.25 into 2.993, and then you also know T1 value. T1 value is given as 4800. From here you can get T2 value. Simplify this. 4800 by T2 is equal to 2.113. E to the power of 0.25 into 2993 will give you the value 2.1133, and then once you simplify, T2 is equal to 2271.3 Newton. So you have found out the tension in the slack side. Tension in the tight side is given. Tension in the slack side you have found out. You can take the ratio and find out the belt tension T1 by T2. Next, you have to find out the power transmitted. Power transmitted is given by the formula P is equal to T1 minus T2 into V by 1000, where V is the linear velocity. Do you know linear velocity? Linear velocity is not given. So you have to find out the linear velocity, and linear velocity is pi d1 n1 or pi d2 n2, you can take it. And if you are taking only pi d2 n2, it is in terms of meter per minute. You have to convert into meter per second later. So pi into d1, they have taken the diameter of the driver pulley, that is r1 is 0.5, d1 is 1 meter. 1 into n1 is 150, which is equal to 471.23 meter per minute. Convert into seconds, divide by 60, you will get V is equal to 7.85 meter per second. Substitute V value in the power equation. T1 is known to you 4800 minus 2271.3 is the tension in the slack side that you have found out in T2. 7.85 is the linear velocity. Substitute, divided by 1000, simplify this, you will get the value as 19.85 kilowatt. So the power transmitted by the belt drive is 19.85 kilowatt. So this is the procedure to find out the length of the belt, and then if one of the tension is not given, you can find out by using the formula T1 by T2 is equal to e power mu theta. Here the angle of contact is also not given. Calculate the angle of contact for an open belt drive using the formula theta is equal to 180 minus 2 sine inverse r1 minus r2 by c pi by 180. Substitute, you will get the value, and then substitute in this formula T1 by T2 is equal to e power mu theta. One of the tension is given, that is tension at tight side is given 4800. Simplify, you will get the tension at the slack side. And then power transmitted, you need to find out power transmitted in the belt drive. P is equal to T1 minus T2 by 1000 into V is the linear velocity. Then find out V by using the formula pi d1 n1 is equal to pi d2 n2. You can use any one of this, pi d1 n1 or pi d2 n2, and then substitute the values, find out the value, convert into seconds. It has to be in terms of meter per second only. Only when you put the velocity as meter per second in power equation, you will get the right value, as kilowatt, or else you might go wrong. So please check the value while you are submitting and substituting. 4800 minus 2271.3, these are the tension, and then you simplify that, you will get the value. So you have to do, or you have to find out the values for a cross belt drive on your own by using the, or by following the procedure whatever I have explained for an open belt drive, and do comment in the comment section about the values that you have got. So thank you for watching. This is about the numericals on belt drives. So do subscribe to my channel InQuisitive, and if you like this video, do share it among your friends and like the video.